lesson, we will learn how to graph a cubic function and the transformed parts of that cubic function. We're going to start with the parent cubic function, which is f of x equals x to the power 3. Now to do that, let's go to y equals, clear that, and enter the function x to the power 3, and then graph it to know how the graph of the cubic function will look like. As you can see, it's an increasing function that goes up and then curves at the origin and continue going up. Now to be able to transform that graph into my graph, I need to go to the table and grab some points. Now 3 points, or in this case we're going to be choosing 5 points, are going to be points that will fit into my graph. So these are good points that I can copy into my table to be able to graph this cubic function. So -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. So let's move those into my, or copy those. Let's copy those into my table. So -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. Now what we're going to do is we're going to plot these points to be able to transform that graph into our coordinate plane. So -2, -8. Then we have -1, -1, 0, 0, 1, 1, and then 2, 8. Now let's choose a different color to connect those. Now remember, you have to have a curve to curve this graph at the origin, because the origin in this case is going to be my point of symmetry. So wherever the curve, or wherever the graph curves, that's going to be your point of symmetry. This is one way to find it. Now let's go ahead and connect those points and curve the graph at the origin. And that's going to be my cubic function. Now again, my point of symmetry, like we discussed, is where my graph is being curved. So basically in this case, it's at the origin. So let's put 0, 0 is going to be my point of symmetry. Now this graph continues on forever, as you can see. There are arrows on the right side and arrows at the left side. It continues on forever. So the domain and range are going to be all real numbers. So it's going to be from -infinity to infinity, and the range is going to be from -infinity to infinity as well. Okay, so that's the domain and range of my graph. Now as for end behavior, what do they mean by end behavior? End behavior, they mean, look at your graph. Look at the right side of your graph. Is it going up or down? So look at the right side. The right side of your graph is going to be up. So as x going to plus infinity, y is also going to plus infinity. So when they say x going to plus infinity, means look at the right side of your graph, and the right side of your graph is going up. So the f of x is going to plus infinity. Now when they say x going to -infinity, it means they are telling you to look at the left side of your graph. The left side of your graph is going down. So f of x is going to -infinity. So this means down. Okay, I'm sorry, I don't know why this keeps on flashing. It seems every time I write on my iPad it flashes, so I'm sorry about that. Now, what are the zeros of the function? The zeros of the function, in this case, it's just 1, 0, and it's basically where the graph touches the x-axis. So the 0 in this function is going to be 0, 0. This is where it touches the x-axis. Another word for 0, remember, is going to be root or x-intercept. Okay? So this is how you graph the parent cubic function. you plot it in your, or you put it in your calculator, you get some points that would fit into your graph. If you get 3 points, that would be more than enough, but for just the sake of showing you how it will look like, I had more than 3 points, but 3 points would be enough. The point of symmetry is the most important point in your cubic function, just like the vertex is the most important point in a quadratic function, in a parabola. The point of symmetry is going to be where your graph curves. In this case, it's at the origin. End behavior, it means look at the right side of your graph. Where is it going, up or down? And then look at the left side of your graph. Where is it going, up or down? The 0 is going to be the x-intercept. The domain and range of cubic function is always going to be all real numbers because it continues on forever. Now let's move on to the second part of our lesson. Now I'm not going to do the odd function. I'm just going to be doing the, I'm not going to do the even function. I'm just going to focus on the y equals negative x to the power 3. So in order to do that, let's put that in our calculator. So let me clear that and let me put negative x to the power 3. Okay? You know what? Let me put this in, I'm going to put x to the power 3. I'm going to keep the x to the power 3 in y1. And I'm going to put negative x to the power 3 in y2 so you can actually see the difference between them. Okay? So the negative x to the power 3 is going to be my red one. Okay? Okay. Now, let me clear that for now so I can actually look at the table so you don't get confused. Let me just put negative x to the power 3 in y2. Let me graph it. So I can just focus on that now, and then we can put the current function. As you can see, just like before, but it's on the other side, it's going to curve as well at the origin. So the origin in this case is going to be my point of symmetry. Let me go to the table and let me get some points from there. Now again, let's pick, usually 3 points is enough, but because I have more than 3 that would fit into my table and graph, let's copy those. So let's go to our table and let's copy those points. So I'm going to copy negative 2, 8. I'm going to copy negative 1, 1, 0, 0, and 2, negative 8, and 1, negative 1. Okay, now let's plot those points. Negative 2, 8. Then I have negative 1, 1, 0, 0, 1, negative 1, and 2, negative 8. Now let's connect those points, but remember, you have to curve at the origin, and that's your point of symmetry. Okay? That's your curve. Now, let me write down that my point of symmetry in this case, it's not always the origin, but in this case, it's the origin, because this is where your graph curves. So my point of symmetry is 0, 0 in this case, and that's the most important point. Now let's go back to what I wanted to do at the beginning, and I'm going to go to y equals, and I'm going to put x to the power 3 over here, and I'm going to graph both of them. Remember, the blue is going to be my parent function, and the red is going to be my new function. Now let's compare them. How are they, if I ask you about the transformation, how do they compare to each other? Now this is the parent function and the red is going to be my transform function. As you can see, it's being reflected over the x-axis. Do you see how the blue, this one, is reflected and becomes the bottom red one? And this blue one of the original function, this one, the blue one, is reflected and becomes the upper red one. So because of the negative over here, this shows me that my new graph, my transformed graph, is going to be reflected over the x-axis when I compare it to the parent function. So let's write that down. The negative reflects the negative, show me that they're going to be a reflection over the x-axis if I ever ask you about the transformation. Okay, and this is it for this video. We graphed y equals x to the power 3, which is the parent cubic function, and we graphed the negative x to the power 3, which is a reflection of the parent function, just the reflection. Now, the other functions that we're going to be graphed are going to be, they're going to have more transformations, and that's going to be in the second video.